All right, class, this is Algebra 2, Lesson 7.1, Radicals and Exponents. Radicals and Exponents. So what we're going to do first is review all of our exponent rules. So that's the first thing here is a review of all of our exponent rules. And this is very slow in responding. All right, so hopefully we can get through that, and hopefully it'll start doing a little bit better here. All right, let's go back. Let's see if we can get this thing going. Okay, so radicals and exponents. So first off, let's start off with properties of exponents. Properties of exponents review. All right, so the first one is the product property. And if you remember in the product property, x to the a times x to the b equals x to the a plus b, right? X to the a times x to the b equals x to the a plus b. So what are you doing with the bases? You are adding the exponents of the bases. So when we do a problem like the example here, you're just going to multiply the coefficients here. Negative 3 times a 5 is a negative 15, right? And it is with the bases, you're going to add the exponents. 3 and 6 is 9, and we get negative 15 to the 9th, right? So you multiply coefficients, you add the exponents of the bases. Again, it's a shortcut to solving the problem, and that's all that is. All right, what happens with quotient property? So you've got the same base, they're being divided. So if you remember, it's the top exponent minus the bottom exponent. Again, the bases have to be the same. Don't neglect that. You know, you've got the same bases there. Both have an x base, and so that's the condition. And when that is the condition, then you simply subtract the exponents. Okay, so on a problem like this, first off, we're going to deal with the coefficients. So a 12 is a 3 times 4. Don't neglect the fact that this is minus, right? Matter of fact, I'm just going to stick it over there right now so I don't forget it. A lot of times students forget it. A 20 is a 4 times 5, and our 4's divide out, right? So what is the coefficient of the top end up being? A negative 3 and the bottom of 5. Now we'll finish our rule with our like bases. So n, top exponent 3 minus the bottom exponent, and in this case, a negative 7. So if you look at this thing, we end up with minus a minus. And so because you have minus a minus, we're going to end up with negative 3n to the 10th over 5, right? Negative 3n to the 10th over 5. Just deal with coefficient divided by coefficient, like base divided by like base. That's all you need to do. Okay, coefficient divided by coefficient, like base divided by like base. All right, how about the power property? So what do you have with the power property? You have an exponent, base and its exponent to another exponent, right? A base and its exponent to another exponent. And the parentheses there is there to help us to understand that. So if you remember, what do you do in this instance? You multiply the exponents, right? You multiply the exponents. Now, the example I have here is a multifaceted example. First off, notice what is and is not the base. And that's the key a lot of times to dealing with exponents. Notice that this parentheses right here determines the base of this 2 exponent. And it's only the things in the parentheses, and therefore only the things in the box. So I do not apply this 2 exponent way out there to the right with this 2, right? Has nothing to do with it whatsoever. And we know that because of the way it's formatted. So to start, we have a 2 times, and now we got to start dealing with this exponent. Okay, so I have a 3. Now there's no exponent shown for the 3, but remember, when nothing's shown, it's actually a 1, right? So the 3 has a 1 exponent, and the x has a 1 exponent. So technically the rule would be 1 times the 2, and then the x, it's 1 times 2, and the y, and it's 2 times 2, and the z, and it's 5 times 2, right? Really what you end up doing is distributing the exponent times the exponent of every factor inside, right? Just end up multiplying it. All right, 3 squared is 9, 2 times 9 is 18, right? So we end up with 18 x squared y to the 4th is z to the 10th. 18 x to the x squared y to the 4th z to the 10th. Just take it one step at a time. Again, I'm trying to give you some pretty complicated examples because we've been doing these rules ever since pre-algebra, right? A lot of these. All right, and look, honestly, by this point, we need to get them down and have them settled. We really need to have the rules down and settled. They come up all the time in math. All right, next situation, zero exponent property. Of course, a lot of people remember that ultimately the answer is 1. But again, do you remember why the answer is 1? And you have to remember that anything to the 0 power is the base divided by itself. Again, we don't have time today to go through why that is the case. We did that in both pre-algebra and algebra 1. But it's the base divided by itself, and therefore you end up with a 1. Now again, notice, it's important that you notice what is and is not the base. Here again, we have a parentheses with that exponent outside of it to tell you what is the base of that exponent. So technically, if I were going to write this out, let me get back to where I was, sorry about that. If I were to write this out, this is what I would get. I would have the negative 2 as a multiplier, and then you're going to have the base divided by itself. Now again, you wouldn't write this step out, but it's 7n squared z divided by 7n squared z, right? And so what do you end up with? A negative 2 times 1, so the final answer on this one is negative 2 because of that negative 2 out in front. All right, pretty simplistic. Again, you wouldn't show this step normally. You just say 1, and negative 2 times 1 is a negative 2. All right, let's do the next one. All right, so negative exponent property. So you have an x to the negative a, x to the negative a. And again, you have to remember what this negative means. Negative exponents says if you want to change from a negative to a positive, you have to do it in the denominator. All right, so this is a 1 over x to the a. Notice how the sign of the exponent changed, right? The sign of the exponent changed. It was a negative, and now it's a positive. The sign of the exponent changed. And look, we usually don't show this, but right now, you know, the original was an x to the negative a over 1. It was in the numerator. X to the negative a in the numerator becomes x to the positive a in the denominator. And so I try to tell you this. If you look underneath the sentence here before we do the example, change the sign of the exponent when taking the base and its exponent across the fraction bar. Across the fraction bar. So let me then also throw this in. If you were to have this 1 over x to the negative a, again, we don't want to leave anything with a negative exponent. I can take this across the fraction bar. And therefore I would end up with x to the a, right? Pretty simplistic. Okay, so what happens when you apply this to the example? So go back up here and look up here at this example. So let's take this n to the negative 3, let's take it across the fraction bar. So here I would have then n cubed, right, on the bottom. Let's take the x to the negative 7, take it across the fraction bar, and I would have x to the 7th. Now the coefficients you would reduce if possible, but there's no reducing of this one. So we just end up with negative 5x to the 7th over 3 times n cubed. And that's it, right? That's all. That's it. Let's do one more rule here. Let me move this up. And so the last rule here is the power of a quotient. So you have a fraction, right? And you have an exponent with a fractional base. The base is a fraction. It's pretty simplistic. You're going to maintain the fraction, but you're simply going to multiply the exponent times each factor, all right, times the numerator, times the exponent of the numerator, and times the exponent of the denominator. So you end up with x to the a over y to the a. So let's apply that simplistically here to our example. So you end up with n to the 2 times 3, right, over 2 to the 1 times 3, or 2 cubed. So where does this thing end up then? N to the 6th over 8, right? 2 times 2 is 4, times 2 is 8. And that's the situation there with the power of a quotient. What do you have? A fractional base. All right, get these rules down. Get them down. We've been doing them again since pre-algebra. Real quick review. X to the a times x to the b equals x to the a plus b. X to the a divided by x to the b equals x to the a minus b. X to the a times x to the b, or x to the a to the b equals x to the a times b. Anything to the 0 power is the base divided by itself, therefore it equals 1. Negative exponents in the numerator become positive exponents in the denominator. Negative exponents in the denominator become positive exponents in the numerator. And then again, a fractional base means you apply the exponent to both the numerator and the denominator. Okay, easy enough. Let's go on to number 2. All right, number 2, any fractional exponent. Any fractional exponent is a root. Any fractional exponent is a root. All right, could be a square root, a cube root. It just depends on the fraction. So that leads to this radical rule. All right, so take a look here in the blue box. X, and we'll look at the exponent. It's a fractional exponent. All right, well, that's real simplistic. We've been through this before. Let me just define some terms again for you and refresh your memory. Don't forget, this is the radical sign. Radical sign. All right, as we complete the rule, you take the base, it goes underneath the radical, and the numerator is its exponent. The numerator is its exponent. So we have x to the a. Now remember, everything under the radical sign is called the radicand. The radicand. It's what you're taking the root of. You take the root of the radicand. And then notice this, the denominator of the fractional exponent is the thing that goes in the crevice, and you remember what that's called? Do you remember the name of that? And hopefully you remember that's the index. Okay, the index tells you what kind of root you have. Square root, cube root, fourth root. This one is a beef root. All right, we want the b root of. All right, that's the way it goes. All right, so take a look at our example here to the right, n to the 1/2 power. All right, remember, we can change the form of this. Radical sign. What is the radicand? N to the first power. We usually don't write the ones, right? And what is the index? The index is a 2, but it's not shown, right? We don't show 2 indexes. Whenever there's no index shown, we know it's a 2 and we know it's a square root. So n to the 1/2 power is actually the square root of n. N to the 1/2 power is the square root of n, and that leads us to my next thought here. So if you look at right here underneath, any base to the 1/2 power is actually a square root. Any base to the 1/2 power is actually a square root. So let's go through and look at our examples here. Top left, 49 to the 1/2 power. Hey, square root of 49. What is that? 7. Go to the right. Let's look right here. 121 to the 1/2 power. Hey, what is that? That's the square root of 121. Again, we don't show 1 exponents and we don't show 2 indexes, right? But the exponent of the 121 is 1 and the index is 2. What is the square root of 121? 11, right? 11 times 11 is 121. Okay, so half powers, anything with a 2 denominator is a square root. Okay. It's really, I wrote half power, but really as long as the denominator is 2, it's a square root. So what do you expect is the case here? What kind of root is this? Not a square root, but it's a, right? And hopefully you're thinking it's a cube root. Why? Because the index is 3. So again, if we put this in a radical form, we have an 8 for a radicand, and we have a 3 for an index. And by the way, what is the cube root of 8? It is 2, right? Remember, let me go through this. We did this in Algebra 1. We did it in pre-algebra. But just a reminder, what does cube root mean? What number times itself? Watch now. Look right here. What number times itself 3 times equals the radicand? Doesn't a 2 times itself 3 times equal the radicand? So what number times itself 3 times equals an 8? A 2 times itself 3 times equals an 8. That's what radicals are, right? That one a cube root. So look at the last example here to the right, this section. And what kind of root do you have here? Well, remember the denominator is the index. We have the 7th root of what? 5 squared. And it's the first one where we actually had a numerator. We're going to use the numerator of the fraction, right? 5 squared. Now, proper form is to go ahead and simplify this. So we would say the 7th root of 25, right? The 7th root of 25 for the 7th root. Cube root, square root, etc. All right, so just a quick recap here of this section. This is an important rule, and this is something you should memorize. And what we're doing is we're taking something in exponent form and changing it to radical form. That's why these sections go together, and that's why we spent time reviewing the exponent rules. We went from exponent form to radical form. And what is it? When you have a fractional exponent, you actually have a root. When you have a fractional exponent, it's a root, right? That's right up here. So that's important, and keep that in mind. Keep that in your thoughts. And so what kind of fractional exponents? Hey, half power is a square root. Third power is a cube root. 1/4 power be a fourth root, etc., 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 etc. All right, let's go on to this next situation here, and that's the products of roots. All right, so what happens when you have a root and you have 2 factors here? We have an x times a y as the radicand, right? Well, we have the right to split this thing up. We have the right to split it up, and they're going to be multiplied. Now, it's still an nth root and an nth root, and you can split up the factors of the radicand. So we have the nth root of x times the nth root of y. Really, what we actually did was factored, right? We kind of factored this thing. We unmultiplied it. And that's why the next rule goes the opposite direction. How do you multiply radicals? How do you multiply radicals? Well, first they have to have the same index, and these do. They both have an n. So it's easy to multiply these. You write that common index, and you simply multiply the radicands. Common index, and you multiply the radicands, right? This is 2 different operations, right? You're going, they're inverses of each other. Okay, so that's the idea. So when you look at a problem like number 3 here as an example, then this is what we're thinking here. You have the right to do this. Now we'll do a shortcut to this later on, but we have the right to split this thing up. And so the indexes are 3, right? Because you have a cube root, and the first factor is an 8, and the second is a y squared. I mean, you could further break it down if you want it into a y and a y, but there's no purpose to that. So note here, what's the cube root of 8? It's a 2, and then times the cube root of y squared. All right, so focus your attention right here. We will normally not show this step. We will simply work right off of the original. And this is what I would do. So look here at the original. Normally we would say, what is the cube root of 8? It's a 2. And what's left? The cube root of y squared. We'll do it right on the original because we understand that it's the same as separating it. Okay? Now, if you can't do this in your head, then just go ahead and separate it and then simplify it and go from there. All right, we'll talk more about simplifying here in a little bit. All right, so last one here, quotients of roots. Quotients of roots. And this one makes sense. Think back to the exponent one, right? And so really quotients of roots, same concept, same idea. And it's going to be the nth root of the numerator divided by the nth root of the denominator. So what's the top? The nth root of x. What's the bottom? The nth root of y. That's all. So applying that to our example here, so we're going to have the cube root, right? They're both cube roots. What's the numerator? 1. What's the denominator? 8. Excuse me. So if we finish this thing out, what's the cube root of 1? 1. What's the cube root of 8? 2. And this thing is actually a half, right? The cube root of 1/8 is a half. Hey, that's the lesson. It's foundational. So make sure that you go back and keep track of things. Let me just review this second page again. It all starts with converting, right, from fractional form to radical form. Don't forget your terms. Radical sign, right? Anything under the radical sign is a radicand. That's the thing you're taking the root of. And then you've got the index. The index tells you what kind of root it is. I want the b root of x to the a. All right? Oops, there I go with that keyboard again. Okay, and so, hey, let me not forget this. Any fractional exponent is a root. Anytime you see a fraction for an exponent, it's a root. Any base to the half power is a square root. Any base to the third power is a cube root. Here's your products of roots rules. And again, we really will use a shortcut in that when practically applying them. And then the quotient of roots, just split it up. The nth root of the numerator over the nth root of the denominator. Okay, that's the lesson. Have a great night.